Okay friends, so let us recap one-dimensional pointers and arrays like int star, ptr, int array, subscripts, and we will quickly see the 2D different things like 2D array, double pointer, array of pointers, pointer to array, all that. So that's the agenda. So let's start with a recap. We had seen what is the difference and similarity between array of integer and pointer to integer. So what is it? Basically, one is that so first thing is we can be clear of the picture that let me just position it accurately. So one thing is, when we say ARR, we mean a pointer fixed to the base address, it cannot move, and it's an array of integers. And when we say PTR, it's a small address variable, it can hold address of something. So they are like that. So now given this, what can we appreciate about these? Let's just see. So basically this array, size of array will be size of the whole thing, size of this whole thing, right? So it will be one element, size of one element into number of elements. Size of pointer will be typically 4 or 8 bytes depending on how much address takes. Okay, so size of is difference. So let me say what is the difference. So one item is size of. Second item is cannot do ARR plus plus or ARR equal to something else. Not allowed, right? Because ARR is like a constant pointer. The pointer itself is constant and it's committed to the base address. It's just here. It cannot move an inch. Okay. And similarity, you can use syntax is the same. Similarity, okay, syntax is the same. So for example, you can say star ARR, which actually means ARR 0, and you can say star you can say PTR 2. So let's say PTR was here, so PTR 2 means move 2 elements, 1 2, so PTR plus 2 is this. So you can PTR 2 and then we are having subscript, so we are basically referring to this element when we say PTR 2. So you are able to use array style syntax on pointer, you are able to use pointer like syntax on array. So that's a similarity. Syntactically they are identical. Okay, and so these are broadly the main points. One thing you please keep in mind, that when you pass a array to a function, let's say you say a void func int ARR 10, and then within the function if you print size of ARR, okay, it will be size of a pointer, because the concept is when you pass an array to a function, it degenerates or decays or becomes a pointer. So right now ARR is just a pointer. Okay, so size of ARR will not do size of the whole thing. You cannot do size of ARR by size of ARR 0 technique to get the number of capacity elements, at least, if not filled elements. So just be careful when we pass an array, it is a pointer. Okay, so that's fine. So one principle which we learn from here is, so let's note the principles. So we are saying array of int is very similar to array pointer to int, and there is nothing specific about int. If instead of int you take double, char, struct, it will be the same. So we will say array of x is very similar to pointer to x, and if you instead of x you write array again, so array of array, so you can say that, okay, array of array is very similar to pointer to array, right? So this brings us to our next topic, the two-dimensional things. So let's consider what is a 2D array. Okay, what is a 2D array? So let me write here, and I will draw some line to delineate, and we are dealing with 2D array now. So we have a matrix. I'll call it matrix because that's the most intuitive example of a two-dimensional structure. So assume there are hash defined max row, max col, and we have a 2D array. So and assume let me give the values so that we can talk. So let's say max row is 3 and max col is 4. So if you have to draw it, always picture drawing always helps. So we can simply understand it as, so it has 3 rows, right? So 3 rows and 4 columns. So my drawing is not great, the lines are not very straight, but never mind. So this is row 0, row 1, row 2. So for example, and this is like 4 columns, okay. And if you think, if you ask yourself what is size of matrix, it will be 3 into 4 into size of int. Assume size of int is 4. Then basically it will be like 12 integers. So 12 integers, 12 into 4, 48. Okay. And if you ask yourself what is size of matrix 0, that's interesting. Matrix 0. What is matrix 0? So pictorially we can understand that matrix 0 is basically this row, right? This is matrix 0. This is matrix 1. This is matrix 2. So the first subscript, when we say matrix ij, the first subscript is row number. So what is size of matrix 0? Size of matrix 0 is size of this array, an array of 4 integers, that means 16 bytes. So let's say 16 bytes. But this gives us a crucial clue that a 2D array is a 1D array of a 1D array. So basically you can see that it's an array of arrays, and the dimension of the kind of inner array, if you want to call it, it's 4 max col, and then I have an array of arrays. Okay, so this is my array's first element, which is another array of 1D array. This is array second, and so on. So this analogy is very important. So given this principle, array of array is very similar to pointer to array, we will understand that this two-dimensional matrix is very much similar to a pointer to array of max col. Okay, so if we think of what is a array having max col integer, it's very no-brainer kind of, this is the array having max col integers. So what will be a pointer to a array having max col integer? Very simple. Instead of array, in a bracket you say ptr to array. That's a nice name. So basically ptr to array is a pointer to array. Pointer to which array? An array having max col integers. Okay, and this dimension has to be given. So if that be the case, then what will happen if I say ptr to array? Let's say it's a pointer and I say ptr to array is equal to matrix. That should be compatible, because pointer to 1D array and array of 1D array, they are compatible. Just like I could point int star ptr to arr, where arr was array of integer. Same exactly same analogy, and you will see that pointer to array, you can point to matrix. You will see that you can increment it. You can say ptr to array plus equal to maybe 1 only initially. I could do plus plus also. So if you do that, basically you are here initially, plus plus, you get to the next element, because now your element is row. Your unit of increment and decrement is 1 element. Okay, so like that it will happen, and pointer to array max col you will find very compatible with a 2D array. In fact, when you pass a matrix to a function, for example, let's say you take this whole thing and you create a function void func this, and if you print size of matrix here, so just like we saw a little up size of ARR here. Okay, so size of ARR here was just a address, worth a address, 4 bytes, 8 bytes. Same way, it was matrix was a 1D array of 1D array, but now it's a pointer to 1D array. A pointer always takes 4 or 8 bytes. It doesn't depend to what it is pointing. So this will be 4 or 8 bytes. Okay, and if you do a matrix plus plus here, it is allowed, although it looks like a 2D array, but it's not. It's a pointer. Okay, so you can do like this, and you can really pass it in 3 syntaxes. For example, here I could pass it in 3 syntaxes. I could say array of specified dimension, that's okay. Array of unspecified dimension, because dimension doesn't matter to the compiler. Compiler only passes the base address, so it ignores the dimension even if given. Or you could say I could just pass a pointer, so int star ptr. So these are the 3 ways we saw they exist in the one-dimensional pointer. When I say one-dimensional pointer, I'm just saying that instead of being in the array dimension, it's like a negative side of the line, I'm getting a pointer, so that consider it that way. So here also you can pass it in 3 ways. You can say it's an array of unspecified dimension, and you can say that it's a pointer to array. So this whole thing you can remove, and you can say ptr to array. Okay, so what you will see is that concepts are very few, principles are few, and if you apply what you learn to array of integers to array of arrays, they exactly apply. So nothing really changes. Okay, so it just applies as it is. So that's pointer to array, and we now have a visualization of pointer to array. Okay, now let's consider array of pointers also. What is array of pointers? So let's say we have int star air of ptr, and I will use max rows here. So now the visualization is that I have 3 elements. Each of the element is a pointer. So you can draw it like this. Maybe you can draw it like this. Let's say you draw a small array, and all of them are pointers. More often frequently they are drawn vertically somehow. You can say that I have 3 rows and there are 3 pointers. So why would anybody do that? Let's say you are dealing with a symmetric matrix, and if you follow this approach, you can allocate 1 element here, 2 elements here, and 3 elements here. So you store only what matters. You don't store AJI if AJI can be reduced from AIJ. So you reduce the storage to half. 3 cross 4, it doesn't matter, but 10,000 cross 20,000, it will matter, right? Or if you consider you are dealing with a sparse matrix, you may say that okay, I will have a head pointers kind of for each row, but then I will only have a linked list, and I will say column number and value, and next column number and value, and similarly a linked list here. So sparse matrix, most of it is 0, the non-zero you store separately. So you can have array of pointers in such cases, that for every row I am having a linked list. So array of pointers looks quite reasonable there. So if you have such a code, then most likely you may have structure like structure of the code is for I equal to 0, I less than max row, I plus plus. Maybe you might do some malloc, perhaps, possibly. You can say that I will malloc, and maybe let's consider that size of that symmetric storage, halving the memory. You may say size of int star I plus 1. For the 0th one, you allocate 1 integer, and then you keep increasing by 1. So this is how you can allocate memory for such a structure. So what I hope is that with this, these sort of difficult concepts we are able to visualize and we are able to think from first principles, and these things have started becoming easy for you. Thank you.